Grade lesson 9.2 is equations and tables, and we'll be using that idea of that independent variable and the dependent variable to kind of take it a step further. And this is really a building block to the way you'll see things go towards slope and intercept as you go into 7th and 8th grade math. So these are foundational pieces. So your understanding of this is super helpful to you. So one of the things to keep in mind is I'll do a quick review of independent variable and dependent variable from our last lesson. In our last lesson, we learned that the independent variable was the piece of information that we were sitting there waiting for, and we must have it in order to solve the dependent variable. So some of the examples were if we went bowling and it cost us $3 per game to go bowling, how much did it cost us to go? Well, the cost of that, the cost of it depends on how many games we bowled. G, the games is the unknown independent variable. Cost, C, is the dependent variable. And so this next step to that is now that you understand that, is usually when we have these two variables going on in a scenario, the dependent variable, the one that's waiting, we can't solve it until we find out the independent variable, is usually represented by y. This usually represents the dependent variable. And the variable x is usually used for the independent variable. So we would, instead of using G for games, we would use X to represent the fact that that's our independent variable. That's the one we're waiting to find out so that we can solve for Y, the dependent variable. And we refer to things like as input output. So if I were to give you this equation of Y equals X plus 3, let's say, well, what I would know is this is the dependent variable. This is the independent variable, and this is the dependent variable. I need to know this in order to solve that. So what we call inputs is that independent variable, the input. So if I input, let's say 2, what I really am saying is, okay, then in place of X, we'll put 2. And that will give me an output. And 2 plus 3, of course, is 5. So if I input 2 to that equation, my output will be 5. If I input 2, input is what I really meant to put there, then my output will be 5. Or if I have an equation like y equals x plus 3, and I input 4, then my output, that means I'm putting 4 there as an input, then my output will be 7. That y will equal 7. So that's the new piece of information that's being added to this. It's just the way usually you will see the independent and dependent variable identified. You're going to put that, you're going to create equations out of information, so it's still translation. We'll use X to represent our independent variable, Y to represent our dependent variable, and then we're going to use a table of information to help solve it. So I'm going to show you all of that. All right, so we will use our steps. We will read this. A skating rink charges $3 for each hour of skating, plus you spend $1.75 to rent your skates. Write an equation for the relationship that gives the total cost Y in dollars for skating X amount of hours. And then make a table that shows the cost of skating for 1, 2, 3, and 4 hours. We'll underline what they want us to do. They want us to write an equation for the relationship that gives the total cost of skating. So what is the independent variable and what is the dependent variable? Well, there's two things I don't know. I don't know how much it costs, right? I don't know how much it costs. That's what they want me to find out. That depends on something else, right? It depends on how many, the skating rink charges $3 for each hour. It depends on how many hours, So cost is my dependent variable. It depends on how many hours, independent variable. And normally we will give the independent variable the name x and the dependent variable the name y, or the variable y. So let's go ahead and break this down. The total cost, oh, I did not circle this, sorry, $1.75 to rent skates. Okay, the total cost, y, is going to equal the cost. This $3 is the cost for each hour. So cost per hour for each hour x. We don't know how many hours. We don't know. Maybe we want to skate for 12 hours, because we like it. Plus this $1.75, remember, represented my skate rental. Oh, sweaty shoes again. Yay. So the equation y equals 3x plus $1.75 is the equation that translates from English to Mathies. Can't solve it yet, right? I've got two variables. I can't solve that until I know how many hours I'm going to skate. So for now, that's all I can do. But then they said, then make a table that shows the cost of skating for 1 hour, 2 hour, 3 hour, 4 hour. And they did make the table for us. So we just have to carry it from there. Our input, 1 hour, 2 hour, 3 hour, 4 hour. This is the input amount for our independent variable. This is just us running through that equation. So we'll plug in 3 times 1 plus 175, then 3 times x equals 2. So here we will have 3 times 2 plus 175. I'm going to use that for times because when I have a decimal over here, I usually avoid using the little dot for multiply, and I go back to the multiply symbol. Otherwise, I get them confused. Then 3 times x when x equals 3. So this will be 3 times 3 plus 175. And then we have 3 times x when x is 4. So 3 times 4 plus 175. I calculate those out. 3 times 2 is 6 plus $1.75 is going to give me $7.75. 3 times 3 is 9 plus another $1.75 is going to be $10.75. 3 times 4 is 12 plus another $1.75 is $13.75. So these are all of the potential costs depending on how many hours you end up skating. So that's what they're asking you to do in this lesson. One of the things they're asking you to do in this lesson: translate, get an equation, and then calculate for a certain amount of certain types of inputs. X equals this, then try it. Calculate, run it through the factory, and out you spit out the y. Okay? So when x is 1, y is 475. When the independent variable is 2, the dependent variable is 775. When the independent variable is 3, the dependent variable is 1075. When x is 4, y is 1375. And so sometimes they give us all the information, the input and the output, and they don't give us the equation. We have to do some investigating. We have to be the detective to find what the equation is. So we'll start by reading this, and then we'll analyze the information we're given. Jamal downloads songs on his MP3 player. Do MP3 players even exist anymore? I'm not sure if they do. The table, they're like they were like an iPod with music, except they were just a different format. I don't know. The table shows how much time it takes. The table shows how the time it takes him to download a song depends on the song's file size. Write an equation for the relationship shown in the table, and then use the equation to find how many seconds it takes Jamal to download a song with a file size of 7 megabytes. So we have to figure out what the equation is. They gave us all kinds of information. Is his download times 4 megabytes will take 48 seconds, 5 megabytes, 60 seconds, 6 megabytes, 72 seconds. They even laid this out this way. And so we can ask ourselves, 4 megabytes took 48 seconds. Well, what happens with 4? What can I calculate by 4 in order to end up at 48, and it's probably a repeated addition. So we're looking at something multiplication wise. So what times 4 is going to give me 48? Well, 12 times 4 will. Is 5 times 12 60? Yes. Is 6 times 12 72? Yes. They skipped 7, that's our unknown. Is 8 times 12 96? Yes. Oh, times 6. So we know that what's happening is the download time, the amount we want to know, is equal to the 12 seconds multiplied by the file size, which we don't know. It depends on what file size he's downloading. So it takes 12 seconds per megabyte, it looks like. That's what we discovered here when we were the detective figuring out what did we do to 4 to get 48. So it takes 12 seconds per file size. So the equation for the relationship is y equals 12x, or y equals 12 times x. And now again they said, what if it's 7 megabytes? Okay, if my input is now 7, then y equals 12x is now y equals 12 times 7, because now I know my independent variable, that's my input. And so my output, my dependent variable, will be whatever 12 times 7 is, 84. So it takes Jamal 84 seconds to download a 7 megabyte song. Oh, okay, I could do that 84 seconds, but if I'm a go-getter, I'm going to take 60 seconds off of there to call it 1 minute, and I'll still be left with 24 seconds. It takes 1 minute and 24 seconds to download a 7 megabyte song. That's a really long time. It doesn't take that long anymore. Not usually, anyway. Hopefully not. All right. Those are the two things you're going to see. The first slide and this one are the two types of things you're going to see as this lesson goes on. So just go ahead and dig into it, give it a shot. I think you'll find that this makes good sense as you go. To me, the detective part is probably the stuff that takes the more thinkiest time. Thinkiest is not a word. It is now. The thinkiest time. To figure out, but then you'll see it. You'll see it. So, all right, good luck. You'll do great.